Here we have the SO4 2- ion, the sulfate ion, and we're going to calculate the formal charges for each atom. So let's start with this oxygen right here. So if you look at the periodic table, you'll see that oxygen is in group 6A or group 16. It has 6 valence electrons, and that'll always be the case for oxygen. When we look at the non-bonding electrons, the electrons that are not between two of the elements forming chemical bonds, we have 2 here and 2 here. So we have a total of 4 non-bonding. And then the bonding, we have these 4 right here between the sulfur and the oxygen atom. So 4 divided by 2. So 6 minus 4, that's 2, minus 2, that equals 0. So the formal charge on this oxygen right here is 0, and we'll put that in parentheses. Next, let's do this oxygen here on the top. We know we have 6 valence electrons for oxygen. Non-bonding, we have 2, 4, 6. And then bonding, we have just the 2 here, 2 over 2. So 6 minus 6, that's 0 minus 1, negative 1. So our formal charge is negative 1 for this oxygen on top of the sulfate ion. So at this point, we could repeat the process for this oxygen right here, but it's the same as this one here. So it's going to have the same formal charge. So we can just put a 0 here. And then on the bottom, we have, again, symmetrical. This is the same as this oxygen up here. And the formal charge for that will be negative 1 as well. For the sulfur atom, if you look on the periodic table, it's in group 6A or 16, so it has 6 valence electrons. And we're going to subtract the non-bonding electrons. For sulfur, all of the electrons are involved in chemical bonds. So we put a 0 there. And then we'll subtract the bonding electrons divided by 2. So we have 2, 4, 6, 8, 10, 12. So 12 divided by 2. So the formal charge on the sulfur in the center is going to be 0. And we've calculated the formal charges for the entire sulfate ion. This is Dr. B with the formal charges for the SO4 2- ion, and thanks for watching.